Welcome to Teolumen Insights, where we reveal the hidden forces that shape the way you live and show you how to use them to create real transformation and supercharge your health, mindset, and daily life. Here are your hosts, Emma Greenwood and Nathan Sinclair.
Welcome to Teolumen Insights, everyone. Get ready, because today we're diving deep into the world of physicist Ervin Goldfain.
Oh, yeah.
You know, you've all sent in tons of his research articles, presentations, even bits from his books. And I got to say, this isn't light reading.
No, not at all. Goldfain's work really gets into some complex areas.
Right.
He's tackling those huge questions physicists have been stuck on for years now, like dark matter.
Oh, yeah.
The origin of the universe, even why particles have the masses they do.
Yeah.
He's going beyond the standard model, you know,
Totally.
pushing the boundaries of what we thought we knew about the universe.
So let's jump right in. One of the first things that caught my eye was his work on fractional dynamics.
Okay.
I have to admit, the term itself sounds a little intimidating.
I can see that.
Can you break it down for us? What makes it so revolutionary?
Well, think about how we usually describe change in motion.
Okay.
Use calculus, right?
Right.
But calculus depends on whole number derivatives. Goldfain suggests that to really get the universe at its most basic level, at those super high energies we see in the very early universe, we might need to use fractional derivatives, those with fractions in them.
So he's essentially saying, our way of doing calculus might be too simple.
Yeah.
That's a bold statement.
It is. It has huge implications for how we understand physics.
Wow.
It challenges the very idea of how things change and move in the universe. Like, imagine trying to map out all the details of a coastline.
Okay.
If you use a big measuring stick, you miss all those curves and inlets, right?
Right.
Fractional calculus is like using a tiny, tiny measuring stick so we can see the universe with a whole new level of detail and complexity.
It's like zooming in on a fractal and realizing there's a whole universe in that tiny structure.
Exactly.
You mentioned Goldfain connects this to the very early universe. How does that work?
He suggests that just after the Big Bang, when the universe was so dense and energetic, fractional dynamics could have been crucial in shaping the forces and particles that make up our reality today.
That's fascinating. So we have this crazy complex, almost fractal-like view of the early universe.
Right.
And then on top of that, Goldfain adds another layer with his ideas about chaos theory and something called bifurcations.
Oh, yeah.
Can you unpack that for us?
Sure. Chaos theory tells us that even in random-looking systems, there are hidden patterns and order.
Okay.
A bifurcation is where a system suddenly changes its behavior. A small change can have huge consequences that cascade down.
Got it.
Goldfain applies this to the universe itself, saying it might have gone through these chaotic transitions, these bifurcations, as it evolved.
So he's saying those tiny changes in the early universe, maybe even to the quantum level, could have led to galaxies, stars, planets, everything we see, almost like a cosmic butterfly effect.
Exactly.
Wow, that's a profound idea.
It is.
And it connects to another key principle. He talks about scale invariance. Now, we know about scale invariance in relativity. The laws of physics stay the same, no matter how fast you're moving. But Goldfain takes it further, doesn't he?
He does. He says scale invariance might be a universal principle, applying not just to relativity, but to everything, every scale of reality. From tiny subatomic stuff to the vast cosmos, the same basic laws could be at work.
So he's looking for a unified theory, one that connects the incredibly small and the incredibly large.
That's one of the most exciting things about his work. And to explore it more, he goes into this mind-bending concept of continuous dimensions.
Okay, now I need some help picturing this. Fractions of dimensions.
Yeah.
What does that even mean?
It's definitely tough to wrap your head around, but imagine a system changing phases, like water turning to ice.
Okay.
At that critical point, it's not fully liquid or solid, it's in between.
Right.
Goldfain suggests the universe might be like that, in a shifting, in-between state of fractional dimensions.
So the dimensions we see are just snapshots of this constantly changing reality.
Yeah.
Wild.
It is, and it connects to another fascinating concept, Feigenbaum Attractor.
Right, the Feigenbaum Attractor, that mathematical thing showing how even chaotic systems can have predictable patterns.
Exactly. Goldfain thinks these patterns might exist in particle physics, hinting at order beneath the randomness of the quantum world.
Interesting.
He suggests The Feigenbaum Attractor could be a hidden blueprint for how the universe builds itself, a guide for complexity coming from chaos.
It's like the universe is playing a symphony, and the Feigenbaum Attractor is the sheet music.
I like that.
Now, about the quantum world, Goldfain also has this idea of fractional quantization.
Right.
I know about energy being quantized, coming in packets, but what does it mean for quantization itself to be fractional?
It's another radical idea that challenges our basic assumptions.
I bet.
Think of a piano where you can only play certain notes.
Yeah.
Fractional quantization is like having extra keys between those notes, creating a whole new range for how energy acts at the quantum level.
It's like adding a whole new dimension to the quantum world.
Yeah, exactly.
But he doesn't stop there, right?
Yeah.
He takes this idea of dimensions to another level with space-time dimensionality collapse.
Oh, yeah, this is where things get crazy.
I bet.
He says that the 4 dimensions of space and time we experience might have collapsed from a higher dimensional reality.
Whoa.
Like a 3D object casting a 2D shadow. Our universe, how we see it, could just be a shadow of something way bigger, more multidimensional.
So he's saying our universe might be a projection of something much more complex and multidimensional.
That's the idea.
That's heavy.
It is. It makes us ask some profound questions about reality and what we can perceive.
For sure.
Goldfain even suggests this collapse from higher dimensions could be the origin of the Big Bang itself.
This is incredible. It's like peeking behind the curtain of the universe and seeing something truly awesome.
That's a good way to put it.
This sense of awe is exactly what makes exploring Goldfain's work so rewarding. You know, he's constantly pushing boundaries, asking bold questions, making us rethink what we thought we knew about the universe.
Yeah, it's a trip.
It's a journey that challenges our assumptions and expands our perspective. Now, before we get too lost in these mind-blowing ideas, I want to touch on another area of Goldfain's research that grabbed me.
Okay.
He proposes this surprising connection between the cosmological constant and those elusive particles, neutrinos.
Oh, interesting.
Can you tell us more about that?
Absolutely. The cosmological constant, it's this mysterious energy, seemed to be pushing the universe to expand faster and faster.
Right. It's a huge mystery in cosmology.
Yeah, one of the biggest.
And Goldfain saying this energy might be linked to neutrinos, those tiny particles that pass through almost anything.
Right. Those guys.
How could that even work?
It is a radical idea, yeah.
It is.
He points out that neutrinos can oscillate, you know?
Okay.
They actually change their identities as they move through space.
So they're like shapeshifters.
Kind of, yeah. It's a weird quantum thing.
But how does that connect to the cosmological constant?
Well, he proposes that these neutrino oscillations, they might actually contribute to the energy density of the whole universe. And that energy, that could be what's driving the accelerated expansion we see.
So you're saying these tiny particles, they could be impacting the entire universe's fate?
Potentially, yeah. It's a big if.
That's mind-blowing.
It is. And it shows how Goldfain thinks about physics, you know? He's always looking for connections between things that seem totally separate,
Yeah, I see that.
finding patterns others miss.
It's like he's putting together a giant cosmic puzzle.
That's a good analogy.
Each theory is a piece fitting into the bigger picture. But I'm curious about how he develops these theories. We've been talking about some pretty abstract stuff.
Yeah, it is pretty out there.
What kind of math is he using to explore these ideas?
You're right, the math behind his work is complex.
I can imagine.
He uses things like complex scalar field theory, quantum field theory, fractal geometry,
I've heard of that one.
and the renormalization group.
Okay, I'll be honest. Those are a bit over my head.
It's heavy stuff, yeah.
Definitely not your average high school math class.
No, not really.
Can you give us an idea of what these frameworks are about, even just conceptually?
Sure. Think of them as different ways to look at the universe at its most basic level.
Okay.
Like quantum field theory, it describes how particles and forces interact.
Gotcha.
Complex scalar field theory deals with fields that have both magnitude and phase, so it describes more complex behaviors.
Right.
You mentioned fractal geometry.
Yeah, the one with repeating patterns.
Exactly. Goldfain uses it to explore the idea that the universe might be fractal at its core, with similar patterns at all scales.
Interesting.
And the renormalization group, that's a tool to understand how the laws of physics themselves change as we zoom in or out on the universe.
Whoa. Okay.
Yeah.
Pretty wild.
So it's like he's got this toolbox of crazy math techniques to build and test these theories. That's a good way to put it.
It's amazing how much thought and rigor goes into this kind of work.
It really is. Takes a certain kind of mind, for sure.
But I want to go back to something you mentioned before, how Goldfain's theories challenge some of our basic assumptions about the universe.
Yeah, he shakes things up.
Maybe one of the biggest challenges is to the idea that the universe is purely material.
Right, that everything is just matter and energy.
Yeah, which has dominated science for so long.
For centuries, basically.
And Goldfain's work suggests that consciousness might not be just an outcome of complex systems, but a fundamental part of reality itself.
Yeah, that's a core idea in his work.
So he's not just talking about the physics, but the relationship between consciousness and reality.
Exactly. He sees a deep link between them.
Fascinating.
He even proposes this field body, which goes beyond the physical limits of objects and connects them in ways we're just starting to understand.
So, like an invisible web, linking everything in the universe, both physically and maybe even consciously.
That's the idea?
Makes me think about things like telepathy or remote viewing, which have been considered pseudoscience.
Right, those fringe ideas.
Could Goldfain's work give a scientific basis for them?
It's an intriguing possibility. He doesn't directly go into those areas,
Sure.
but his work does open up new ways to explore how information and energy move across vast distances, maybe even influencing things in ways we haven't imagined yet.
It's like he's opening a door to a whole new understanding of the universe, one not limited by what we currently think is possible.
I agree with that.
And speaking of pushing those limits, I have to ask about one of his most interesting applications. Remote metabolism.
Oh, yeah, that one.
Sounds like sci-fi. What's he talking about?
It builds on the idea of those interconnected field bodies we were just discussing.
Okay, remind me.
So he suggests that theoretically a system could take energy from another system, even if they're far apart, by sending what he calls negative energy signals through these fields.
Wait, negative energy signals?
Yeah, no, it's a weird one.
How can energy be negative?
It's a tough concept, but he bases it on his idea of zero energy ontology.
Okay.
Basically, he says the universe might be a balance of positive and negative energy states.
So instead of energy always being positive, there could be a negative counterpart.
Right, kind of like a mirror image.
Interesting.
And by sending a negative energy signal, a system could pull positive energy from another, even across huge distances.
So wireless energy transfer on a cosmic scale.
Basically, yeah. That's the idea.
What would the implications of something like that be?
The possibilities are pretty crazy. Imagine unlimited energy sources.
Whoa.
Or space travel without needing fuel.
Wow.
It would revolutionize how we think about energy and open up so many new tech advancements.
It sounds like we're stepping into a future where limits we thought were unbreakable are suddenly possibilities.
It's a very different way of looking at things, that's for sure.
But I'm curious, how does the scientific community see Goldfain's work?
Some of these ideas must be met with skepticism, right? Especially since he's challenging some pretty deep-rooted scientific ideas.
Oh, absolutely. Some of it is controversial.
I figure.
That's often how it is with truly groundbreaking work.
Yeah.
You know, it pushes boundaries and makes people rethink what they believe.
Right.
Some might say he's too speculative,
Yeah,
but others see his work as a breath of fresh air.
I can see that.
It expands our scientific perspective.
It's like he's shaking things up, reminding us that science isn't about holding on to old beliefs, but about constantly questioning,
That's exact.
exploring, and pushing the limits of what we know.
It's about being open to new ideas.
Yes.
Even if they seem radical at first.
Totally agree. That's what makes exploring Goldfain's work so exciting.
It's an adventure.
It's a journey into the unknown, a quest to find the hidden truths of the universe and our place in it all.
And what a journey it is. So many twists and turns. It's taken us to some pretty mind-bending places. We've covered so much, from fractional dynamics and chaos theory
Lots of brown covered, yeah.
to those incredible concepts of continuous dimensions and space-time dimensionality collapse.
It's been a wild ride through the frontiers of physics.
Absolutely. But before we wrap up, I want to touch on one final point that really stuck with me.
Okay, what's that?
This idea that our current scientific way of thinking might be too limited.
Mm-hmm.
Goldfain seems to be calling for a bigger, more holistic approach to understanding reality.
He's definitely pushing for a broader view.
One that recognizes how interconnected everything is in the universe.
Everything's linked. Yeah.
Even the connection between consciousness and the physical world.
Right. It's all part of the same fabric, according to him.
It's like he's saying we need to step out of our little box and see the universe in a whole new way.
Yeah, a much bigger picture.
One that includes the connection between everything.
Right, from the tiniest particles to the vast cosmos.
It feels like he's urging us to embrace a view that acknowledges how intertwined everything really is, you know?
Absolutely. Everything's connected.
Even the relationship between consciousness and the physical world.
It's a profound shift, that's for sure.
It really is. Instead of seeing ourselves as separate from the universe,
Just observing from the outside.
Goldfain's work makes us consider ourselves as participants in this grand cosmic dance, intertwined with reality itself.
Beautiful way to put it.
It reminds me of Carl Sagan. We are made of star stuff.
Oh, classic Sagan.
But Goldfain seems to take it further.
He does, yeah.
He's saying we're not just made of the same stuff as the universe, we're fundamentally connected to it on a deeper level.
Deeper than we can even imagine, maybe.
And that connection might not just be physical, right?
Right.
His theories about consciousness and those field bodies suggest a deeper, more subtle interaction.
Something we're just starting to get a glimpse of.
It's like he's opening up a whole new world of possibilities.
For science, for sure.
Not just for scientific discoveries, but for how we understand ourselves and our place in the universe.
It changes everything, really.
It's both humbling and incredibly inspiring.
Totally agree.
Goldfain's work reminds us there's so much we don't know, so much to discover.
It's a vast unknown out there.
And that feeling of wonder and mystery, that's what drives real scientific exploration.
Keeps us going, keeps us curious.
It's the fuel that makes us keep asking questions, pushing the boundaries, searching for those deeper truths hidden in reality.
It's about embracing what we don't know.
Yes.
And challenging everything we think we know.
Exactly. It's about recognizing that the universe is way stranger and more complex
And more connected.
than we ever imagined. Well said. I think that's the perfect way to end this.
A good note to finish on.
It's been amazing exploring Ervin Goldfain's mind-blowing theories with you.
Likewise. Always a pleasure diving into these ideas and sharing them.
And we hope you, our listeners, found this deep dive as fascinating and inspiring as we did.
It's quite a journey.
It's a reminder that the universe is full of wonder and endless possibilities.
Never a dull moment.
And who knows what amazing discoveries are waiting for us if we just keep exploring, keep asking questions,
And keep an open mind.
and never stop pushing the boundaries of what we think we know.
That's the spirit.
This has been Teolumen Insights.